14 is asking us to find the difference quotient. So my difference quotient is right here. So I'm going to start by putting a lot of parentheses. Okay, so this first part here, this f of x plus h, that is the function with x plus h plugged in. So if I look at my function and plug in x plus h, wherever I see x, that's what I want to put here. The next part is f of x, which this is really just the function itself, or the function with x. So I'm just taking a copy of the function. And from here, it's a lot of simplifying. So the first thing I want to do is worry about this binomial that's being squared. Whenever you square a binomial, it's essentially a hidden FOIL problem, because you're actually writing that 2 times. I'm going to distribute my negative here, so that'll be negative 3x squared minus 2, and this is all over h. And like I said, you want to FOIL that one. Let's go to the next screen, and I'm going to FOIL it before I distribute the 3. That should get you x squared plus 2xh plus h squared, and then you'll notice that the 2 and the minus 2 are going to cancel out, leaving you with minus 3x squared all over h. Next, I want to distribute that 3, so it's going to be 3x squared plus 6xh plus 3h squared minus 3x squared all over h. You'll see that the 3x squareds cancel out, and I'm left with 6xh plus 3h squared all over h. And then I want to actually factor out an h out of the top. So that will leave me with 6x plus 3h all over h. And I do this because the h's now cancel out. And that's going to leave me with 6x plus 3h. So this is not a nice answer like negative 2 from number 13, the previous problem. But that's because there isn't a constant slope. There isn't a constant rate of change. This is our equation for the rate of change of this graph. So it is not just a number, it's actually another equation. But again, that's more important for calculus.